we are supposed to re-express w minus 1 over w plus 1 into the form of k tangent half theta, where k is a complex number. And we are supposed to find this complex number too. We have two choices, which is to work on this as if it is the trigonometric form or the Euler form. I think the Euler form is actually going to be easier. Let's give the Euler form a try. So we have this minus 1 divided by this. This will be e to the power of I theta plus 1. Because we have a good strategy for an expression that is like this, what we can try to do is to do a factorization of e to the power of half I theta, and this will be e to the power of half I theta, because this times this is going to give me e to the power of half I theta plus half I theta, which is I theta, minus e to the power of minus half I theta. Because this times this, the power will become 0. E to the power of 0 is 1. I'll do likewise for the denominator. So the denominator, we will factorize out e to the power of half I theta. And this will be e to the power of half I theta plus e to the power of minus half I theta. And this can be cancelled. I'm going to be left with this as the numerator and this as the denominator. And they are pretty effective in terms of compressing the complex number, because we have here one complex number and its conjugate. The same thing goes for the denominator. So let's see what we are going to be getting if we were to take one complex number minus its conjugate. This is going to be, if I were to re-express it back into the trigonometric form, this will be cosine half theta plus I sine half theta minus its conjugate. The conjugate will be cosine half theta minus I sine half theta. We will do the same for the denominator. So for this is cosine half theta plus I sine half theta plus its conjugate. So it is going to be cosine half theta minus I sine half theta. In the numerator, immediately cosine half theta and cosine half theta can be cancelled, and these two, they will be added together to give me a 2I sine half theta. As for the denominator, the imaginary portion will disappear, so the two real portions will be added together. It is 2 cosine half theta. So 2 and 2 can be cancelled. We will be left with an I. Sine over cosine, this is going to be equal to tangent of half theta, which is the expression that the question wants us to show, which means that k is going to be equal to just simply I.